Hi, I'm Callie Struskop, and I am a site reliability engineer. And this is the Deploy in Public workshop. This is challenge number 7. So if you haven't started at challenge number 1, I recommend backing on up and starting there because all of the challenges build on one another. And the final piece of the puzzle is that we'll be able to push changes to our application up to GitHub, and then our application will magically, not really magically, because you're going to put a lot of work into it, but your application will be redeployed and your changes will be live. If that sounds fun, keep watching. If that doesn't sound fun, I'm not really sure what would be fun for you. Just kidding. Thanks for watching.
All right, in this challenge, we are deploying a full stack application using EC2. All right, so we have an API, which essentially is the same API as we had last week. I haven't made any changes to the Docker file. I did make a few changes to the app itself, just to make it work better with the front end the way I wanted it. So for example, if you look in well, first, if you look at main, you'll see I added this core is true. The reason for that is because locally, I'm sending a request from a different port to the API. And so you have to have this core is true in order to make that request actually work without hitting a CORS issue. All right, so I added that for you so you don't have to debug that. The next thing that I changed is, well, and I can remove my console logs, is before I had this ID being sent in the body, but that doesn't really make sense, so I don't know why I did that. So I changed it to being a param and added it to the kind of like request URL. And that's like the more standard way that you would do it, which we'll kind of go over that. So what I would do if I were you is, and obviously I added it to an API folder, so that way then I could copy in my front end. So what I would do is I would go to the repo that I gave you in this challenge, and I would just copy the API folder, and I would copy the front end, and I would put them into your repo. And just the only thing I would leave in your repo before copying over API and front end is the .github folder. You can make use of branching to do this, so that way you don't overwrite anything. Just go ahead and do like, I'll show you. You can do get checkout dash B and then name your branch. If I spell checkout right, maybe like with front end, that's a terrible name. But anyways, and click enter, and then you would have a new branch where you can then push all of your work. Okay, but that is just how I would do it. All right. So the GitHub folder, same exact workflow as last week, so it's not going to do anything. API, same, except a few little differences. And then now you have a front end. So I'm going to show you first how we get everything up and running locally, just to make sure everybody understands kind of the structure and how things work. So the first thing that I would do in my terminal is you have to cd into, let's start with the API. So we're going to cd into the API folder, all right, because that's where our server is. And then we'll do npm, let's just do npm install just to make sure. All right, we're up to date, and then npm run start :dev. And then I think I might get an issue, yeah, because I have another one running. So let me just cancel my other application, my other window. All right, and then let's try this again. All right, perfect. So we went and mapped, we connected successfully to the database. All right. Something I would do though too is, so I'm actually going to cancel out of this. I don't think I changed anything on my table, but just to be sure, what I would do is I would actually, because this is just like a practice, I would refresh my tables. I'm actually going to drop my tables just to make sure it's up to date. And the reason I'm doing this is because I'm working with like 5 different repos, testing out different things. And I just want to make sure that none of my repos have different database configurations and are messing things up. If your to-do entity file looks the exact same as what you have in the database, you're probably fine. But I'm just going to go ahead and do npm run migration generate, which should say that there's no issues. Oh, it did generate one. Curious. What's the difference? description done. All right, so I'm going to actually now just drop my migrations to just getting a clean. All right, so we got one clean migration. Then I'm going to do npm run migration run to get just a clean table, and it looks like everything was created. So then I'm going to go back to this and refresh, and let's view the rows, which there shouldn't be any data in it, and get title, description done. Okay, perfect. So that is what we want. All right, that just makes sure it's nice and set up and clean, and we won't run into any issues. All right, so now we can go back and start our server. Okay. So then I'm going to add another terminal. What I'm going to do is I'm going to rename this one API, so that way I know that this is running my API. Okay, then I'm going to go to this terminal and I'm going to cd into, you guessed it, the front end. All right, so now I'm in this folder, and then I'm going to do npm install, so that way I can install all of the packages, and it should actually install everything because I have never run the front end on this. Oh, okay, just kidding. All right, and then let's go to our README because I used Vite and I'm not super familiar with Vite. Interestingly enough, I don't see what the command is. So let me look this up. Vite npm run. Okay, npm run dev, I think is what it is. npm run dev. There we go. All right, so now we have this URL and we have our app. All right, so if you go, let's now pull this over. So we have our to-do list, what needs to be done. So I'll just do like to-do 1, description of to-do 1. Let's test it. So we're gonna add it, and we added a to-do 1. Let's go ahead and check our PG admin, and woohoo, we have that there. All right, let's go ahead and refresh the page, make sure that persists. It does. If we mark complete, that change persists. Let's go ahead and look, and now done is true. Perfect. Let's edit the name. So let's say edited to do 1. Check if the change persisted, and it did. And then let's say something like edited description of to do 1. All right, refresh. Refreshing should pull from the database again, so it should do it automatically. But if you want to be extra sure, you can refresh your database and look. All right, so let's make sure we understand what's happening on the front end. All right, so we're going to go in the source files. So this is a React app. So if you look in the main.tsx, that's where everything starts. And you can see it's rendering the app component. So that's where we'll go next. All right, so in the app component, let's take a look at what we have. Now, also, I just want to put this out there. I made this very quickly yesterday. This is not like React best practices necessarily. It's just I wanted something for us to deploy. Okay, but I mean, you can use it. Feel free to play around with it if you want to make edits to it. You do you. Okay, so we're using a use effect, which basically just gets triggered when the component is loaded to go ahead and get our data. All right, so we're making an Axios GET request to localhost 3000/todos, which if you look at our API, right, /todos, get route is how we get all of our to-dos, okay? So then we are setting the to-do list, right? If you look here, we're mapping over the to-dos, and we're having so basically we're like looping over all of the to-dos in that list, and we only have one, and then we're creating a little to-do card for each one, all right? We also have our form up here, right, with an input for the title and a text area here. All right, and when we click add, you can see that it's gonna again make an Axios request to the back end to add a new to-do, and then it's gonna update my to-do list. So whenever I click add, it's gonna go add it to the database, get the updated list, and set the updated list to the to-dos. So if we added another to-do here, and we click add, you'll see it's going to pop up. If I refresh my page, it's getting all the things. So now those are 2 of our requests, right? The third request, you probably guessed it, is when we edit a to-do. That's going to be specifically on our to-do component. So if you look in the to-do component here, you will see that I probably could have done a better job separating this out into better components, but that's fine. Basically, if we click the complete or incomplete button, it's going to call edit to do. Edit to do basically is going to take a key. So basically, what do you want to edit? Do you want to edit the done? Do you want to edit the description, or do you want to edit the title? And then the value of what you want, which will either be a string for title or description or a Boolean for done. All right. Then we are going to get the entire updated to do because we're using a put request, and put replaces the entire thing. So that's just going to use the spread operator to get the entire to do that we're editing, and then adding in the key and value. And because the to do is an object, it's just going to overwrite whatever that key is. And then we are going to make the Axios request to actually go find that to do in the database, edit it, and then remember it will. If you remember this, that Axios request, the API endpoint returns the updated list of to-dos. So then we are going to update the to-dos, which essentially just sets this list. So I'm going to mark it as complete. It goes into my database. It makes the edits it needs to. It returns all of the to-dos, and that's re-rendered. So that's pretty much the application. Okay, that's how it works. Now we need to deploy it. All right. We are going to use Docker to deploy it. So I am going to try to locally get Docker up and running and see if we can use Docker locally to serve the front end. All right. So when you locally run your front end, you do npm run dev using Vite, right? And that what Vite is doing is it's creating a little server for you, and then it's building your application and it's running it for you. All right. That is nice for local development, but you don't want to do that in production. Okay, so that's not actually how you use the Dockerfile in a production setting. Okay. So what I am going to do instead, and this is going to tie back as to like what we were doing in the first week of deploy in public, is I am going to use an Nginx server to serve my React application. Okay, so when you build your React application, you're essentially just getting some static files that then you can serve. And so Nginx is going to do that. I bookmarked this tutorial, which is essentially what we're going to follow for this. All right. So you put your Dockerfile first in your front end. So I'm going to open my front end, create a file, and then I'm going to create my Dockerfile. All right. It's going to be empty to start with, and that's totally fine. All right. So you can see that they're using a different like app image to use. I'm going to go ahead and just for simplicity, I'm going to use the same image that I used up here. And I'm going to use this platform Linux AMD so that way we don't get any issues when we deploy. All right. So then we can still do the work dir /app because this is going to, in our container, set our working directory that we're going to work out of, that directory that we're going to use for all of our files as app. And yep, we will go ahead and copy the package JSON over. Perfect. And then instead of running run npm install, we're going to do run npm CI, which is, I believe, clean install. And that is going to be a faster alternative for us. Let's go ahead and see if GitHub Copilot can give us a little explanation of what npm CI does. All right. Here's what it does. Come on, Copilot, tell us. All right. So yep, it's clean install. It's typically used in automated environments, test platforms, continuous integration and deployment, or any situation when you want to make sure you're doing a clean install of your dependencies. It requires a package lock to be present. So right, that's why we have this star here, because it's going to copy over our package JSON and our package lock JSON. All right. This command is similar to npm install, but it will delete the node modules folder and install all the dependencies as specified in the lock folder. This ensures that you get the exact same dependencies every time you build, leading for more consistent builds. All right, perfect. So we could actually probably update our backend API, our backend one the same, and we'll give that a try, and hopefully it doesn't break everything. All right. So first we are going to copy over our package JSONs. So basically what it's going to do is it's going to compare the dependencies in package JSON to the package lock and make sure that they're the same. All right, the next thing that we're going to do is copy over the rest of the application. And then we are going to, we are going to run npm run build. All right, so this is going to build the static files that then our Nginx image is going to serve. All right. Yep. All right, so npm run build will run the npm run build script from the package JSON, which will generate a build directory of all of our code to be minified, streamlined, and bundled together into static HTML, CSS, and JavaScript files. This build is highly compressed, optimized, and ready for production. We will use this build to serve. Okay, so basically what we're doing is we're using, it's similar to how in your GitHub workflow you have multiple jobs and you do one job first and then you do another job. That's kind of what we're doing here. We're going to do one job, right? We're going to build our static files and then we're going to create another layer here, which is going to be serve those with Nginx. Okay. So, that is what all of this is going to do. Okay, so if you remember in our first week, we went in and changed our Nginx configuration file and we added this like server listener, right? And then we said what we want to do when we hit that home like index route, okay? So we're going to do the same thing here. All right, so we're going to create a file and we're going to call it nginx.conf. Oh, and mine already exists because I copied my answer key over. So I'm going to delete that because we're not going to cheat. All right. And then we're going to say nginx.conf. Although honestly, I'm pretty much just copying this as is and then pasting it in. All right. So here, basically, we're listening on port 80, which is Nginx port. All right. And we are going to say that when we get a like ping at this location, what we are going to do is we're going to actually serve the HTML file that's in user/shares.nginx./html. Okay. That's essentially what all of this is doing. And if we want, we could go ahead and have Copilot explain it to us too, just to make sure. Because why not? Make sure that we fully understand everything that we're doing. All right, so let's break it down. Let's do it, Copilot server. This block defines a server that listens on certain network addresses and ports and is configured with various parameters like the document root and locations of different resources. Listen 80 is the directive Nginx tells Nginx to listen on port 80, which is the standard port for HTTP traffic. All right, perfect. And that's what's happening. We're having HTTP traffic come in and Nginx is listening for it. Server name localhost. This directive, here, let's open this wider so we can see the whole thing. So the server name localhost here sets the server name to localhost. This means that the server block will be used if the host in the HTTP request matches localhost. I'm not sure I fully understand that one, so we're going to put a pin in it. The directive sets the root directory request to /proxy. This is the directory that will be used as a base for any file paths. All right. Okay, so this is rate limiting how much they can do. So we probably don't need some of this. It's probably some extra. All right, so this is the block that says what we should do if that root URL / is pinged. It's saying that the directory sets the root directory for request to this location. Any file paths in the request will be relative to this directory. So if we hit this, we're actually going to this. This directive, so this line here, specifies the default file to serve if a directory is requested. If a request is made to a directory, Nginx will first try to serve index.html, then index.htm. All right, I feel like some of this is like overkill. So honestly, maybe after we get it working, maybe we'll go ahead and try to make some edits to it. All right. Try files. This tells Nginx to try to serve the files at the path specified by URI. The request URI. If that doesn't work, it will serve index.html. All right, so, okay. And then in summary, the Nginx configuration sets up a server that listens on port 80, serves files from the proxy directory that has specific behavior, and it also applies rate limiting. So, yep, it's just basically forwarding our traffic from when we have an HTTP request, it's going to serve whatever is in this folder here. All right, so we need to make sure then that our front end is putting something in that folder. All right, and so that's where we have this part here. All right, so we're just going to say that this is going to be we're going to refer to this step as build. All right, so that way later we can go ahead and make references to that build step. So yep, we can say from Nginx latest as prod. So now we're going to refer to this step that we're doing here as prod. Okay, so we're going to copy -- from, and then we're copying from the build stage. And then we are going to copy /app. And then it says /build, but when you actually build using it, like when you actually go ahead to build, like let me show you. So if I run, right, so at the end of the day, it's going to run npm run build, right? So if I run npm run build, you can see that a dist folder pops up, and that is where all my assets are going to be. That's where my index.html file is loaded, and then my JavaScript and CSS, right? So I don't know why it says /app /build, because that's not going to work. What we actually want is /app /dist. All right, and then, yep, we are going to put it. So basically, we're going to copy from the build stage the folder that's in the files that are in the folder /app /dist, right? App is our working directory where everything is at. When we run this npm run build, it creates a dist folder with all of our assets in it. So we're going to take everything that's in that folder, which is the assets, so our JavaScript, CSS, and our index.html file. We're going to copy those static files, and then we're going to put them in the user share Nginx HTML folder, right? And if you look at our conf, you're going to see that that folder is what we're going to serve when we hit the Nginx endpoint. Okay. Perfect. All right, so we got to do that. Then what we need to do is we need to copy over our nginx.conf, right, which is in our folder here, and then we're going to put it into the file where the configuration is in, like just normally in Nginx. Yep, that's fine. Let's expose port 80. Sure, we can add TCP. And then kind of, so I'm just going to copy this, and then let's co-pilot this because I didn't look into this enough as to what this is doing, and I probably should have. It works, but let's make sure we understand it too. All right, so the command instructions, the default for executing the container. All right, so yeah, this is the part that these commands here. So this user sbin nginx, this is the path to the nginx executable. When the container runs, it will execute this program. All right, so this is saying like, let's start up nginx. All right. This is a global, allows you to set global directives out of configuration file. Daemon off. Okay, so Nginx by default runs in the background in daemon mode. The daemon off directive tells Nginx to run in the foreground. Oh, okay. So this is basically saying like run in the foreground so that way Docker knows that you're running so it doesn't stop your condition. And this is just saying, let's get things started. All right, perfect. So now we have our Dockerfile and our Nginx configuration file. So let's go ahead and build and run our Docker file. All right, so let's do it. So I'm going to clear this. So yeah, we need to be in the front end folder so that way we can just use the dot at the end. So we're going to say docker build -t so we can name it. I'm going to name it front end. And then and then I'm going to do just a dot because that is going to say, look for the Docker file within this folder that we're at. And it is building. I'm going to go ahead and pause it while it builds just in case it takes a while, although it's pretty fast. All right, we finished building, so now we can run it. So I'm going to say Docker run. We'll use the detached mode so it doesn't take up our entire window. I'm also going to use --rm so that way it removes it after we stop it. And then we'll do -p and then we'll say port 80 to port 80 and then --name and we will name it front end. And this is naming our container. All right, and then we will use the name of the image, which is front end. All right, so now that's running in the background. So we should be able to go to localhost at port 80 and we see our, what's it called? We see our application. We're able to make edits to it and they persist. And we're able to add new to do, blah, 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 new to dos. All right, perfect. So now we know that our Docker file works and it is, oh, by the way, it's, if you are wondering how it's connecting the backend, because we're not doing the backend, it's because all of our requests are to localhost 3000 and our API is running on localhost 3000. All right, so now we are going to actually terraform our resources, but we should probably look through and make sure that we are terraforming the correct resources. All right, so we got a lot of stuff here, which if we have time, and honestly, hopefully we have time, we are going to try to clean this up. All right, but let's focus first on what we need. So the biggest thing that we need, and let's go ahead and kind of minimize this a little bit. Let's look at our workflow to kind of guide what we're doing. So we are building our Docker image for our API right now, and then we're deploying it to EC2. So essentially our goal will be to duplicate, right, these jobs. So we would have 4 jobs total. This one would build the API image, and then this one would deploy the API image. Then we'd have a build front-end image and deploy a front-end image. All right. So what we want to focus on right now is just let's figure out how we get that build done. Let's make that the goal of this video, and we'll worry about the deploy part later. Maybe we'll even do it manually. All right. So when we build an image, what are we doing? We are building it using Docker, but where are we pushing it to? We're pushing it to ECR. All right. So we are going to need to make sure that our ECR, Elastic, what is it? What does ECR even stand for? Elastic Container Registry. We want to make sure that our Terraform for our Elastic Container Registry makes sense. All right. So let's go find our ECR. All right. And you can see that we have a resource for our ECR Elastic Container Registry. All right. And it's just going to be this. All right. And that's fine, but this is going to create one repository. And what we want is we want to create 2 repositories. We want to have a repository for our API, and then we want and to store our API images there, right? Because we have a Docker file for our API, and then we have a separate Docker file for our front end, and we want to have it there. So what I'm going to do instead is I'm going to rename this, instead of AWS ECR repository, ECR, because that's redundant, we're going to call this front end. All right. And then here we'll have var app name. And then instead we're going to have of it just going to dash ECR, we're going to say dash front end dash ECR. All right. Then I'm going to take this, and also I'm going to add on here force delete true, which should, allow us to, when we are trying to deploy our, Terraform destroy all of our Terraform code, it should allow us to destroy, even if there are images in our repo, so we don't have to manually go back and do that. All right, so now we have one for our front end. So let's go ahead and copy this block. And we're going to do the same thing for our API. We're going to highlight this, Command D, so I can highlight both of those and change that to API. All right, so will there be things that we need to change after this step? Probably, but let's just start with small goals. We want to be able to build and push an image to our ECR, so we need a repository to do that. So now that we have that, I'm going to go ahead and say Terraform apply. Oh, and I forgot. We are going to need to do Terraform apply, and then I think it's like, what is it? Terraform var file. I already forgot what I'm supposed to do. Let's see. Am I missing it? Dash var. All right, there we go. So dash var dash file is equal to, and then what is it? Secret. Nope. Secret dot tf vars. You can do it, Terraform. Did I name that right? Yeah. It's going very slowly. All right, I'm going to go ahead and pause this here. Well, let me go ahead and say yes. And then I'm going to pause it so you don't have to sit here and wait for my Terraform, and I will be back in a second. All right, just wanted to update you. We are still creating our resources, and I opened up my GitHub Actions secrets so that way we can edit those as soon as we have them. I once again needed to create a new access key and secret access key for AWS, but I actually updated all of my repos while the Terraform was creating, so that way I won't have to do it, hopefully, again. All right, I'm feeling impatient, so I'm going to kind of let this keep going, but I'm going to switch over to my main YAML file from my simple API, which is no longer a simple API, and I probably named this repo poorly. But anywho, let's go ahead and let's figure out what we need to do to this file in order to build our front end image. So the first thing that I'm going to do is I'm going to change the name of my job, and I'm going to call this build API instead of what we had it before, which was just build. And the reason why I'm doing that is because I want to be able to have a build API and build front end job. All right, this is going to cause issues here because our deploy step needs something called build, and we don't have a job called build, so we're going to have to change that here to build API. I'm also going to change this step to deploy API. All right, next. All right, so I have this whole build API step. Let's take a look at all of the things in the steps and see what might need to be edited in order to make this work. Okay. So here we are adding in our AWS access key ID, and you know what, that should be fine. That would be the same whether we're building a front end or API image, and same with our secret access key, and same with our region. All right, The next thing that we are doing is logging into AWS ECR, which isn't using anything, and and that like from our environment variables. The next thing is going to be build and push. I'm going to change this to API image to ECR. And here we have our ECR registry. And this makes sense. We only have one registry, but we have two repositories now. So this part here where we're just getting secrets ECR repo, that doesn't make sense and it doesn't apply anymore. Our secret's going to be wrong. All right, so we want to go ahead and change this. All right, so what I'm going to do is I'm going to delete this because you can't rename a secret. All right, then I'm going to go ahead and I'm going to put in here instead that we are going to have, what should I call it? I'm going to call it, all right, so it was ECR repo. So I'm going to say front end. Okay, perfect. Front end image repo. And let's go and look at what we had. Let's go to ECR, which that should already be created. All right, so it's coding with Kali front end ECR. So let's go ahead and add that. Perfect. So now we have this front end image repo, and let's create another secret, and we're going to call this API image repo. Good job, Callie from yesterday, who created these in a different repo, and GitHub is remembering it. All right, and we'll paste that in. Okay, so now we no longer have a secret called AWS ECR repo, but we do have one that's called API image repo. And so that is what we're going to use to put into this ECR repository variable. I'm not going to change the name of this because this is going to help me only have to change something in one spot versus changing lots of things. All right. So then the rest of this should be correct. All right, so we should then be able to highlight all of this and copy the build API step. And we should be able to paste it in. It's yelling at us because you can't have two jobs with the same name. So then we're going to call this build front end. All right, so let's say build API Docker image, and then we're going to say build front end Docker image. All right. So, yep, we're still going to configure our credentials. We'll still log into ECR, and then we're going to push our front end image to ECR. So instead of API image repo, we're going to use front end image repo. And the rest should be the same. All right. So this step doesn't depend on anything. I'm going to have our jobs running in parallel. All right, so let's go ahead and open our Terraform, and it looks like we have added everything, which is great, but that means that we still have a few more things that we need to edit in here. So the first thing is going to be database host. So let's go ahead to our database, which would be in RDS. And then let's go to our instance here. And let's grab our endpoint. And we'll edit this secret to reflect our new database host URL. Password and username should be the exact same, and then instance IDs. Also, this would probably be a great thing when we edit our Terraform to have output that shows us these things. All right, so we got to get our instance ID. This is 1. Perfect. Then let's go back to our instances. Let's get our instance ID 2. And let's paste it in. All right, so what do I expect to happen when I push my changes? I expect that my API will build. I expect that my front end will build, and I expect that my API will deploy. Okay. Now we do have one issue that's left. All right. So if you look, we see that we're running the command build. All right. And then we are saying that we are going to build from the current folder that we're like in, right? But if you look now, our Docker files are not just in like the normal repo folder, they are in API and front end. So we're going to need to change that to /API for the API build. And then for the front end build, we need to change it to /front end. All right. So I'm going to open up a new terminal, and I like to have a new terminal and rename it Git. And then I can say Git status, Git add, Git commit, and I'll try to be a real developer this time. I'm also just kidding and add a message here. Added front end and front end build job. Oops. Commit, and then I can push. All right, pushing is going to go ahead and trigger a build. I hope. I think my internet must be really slow right now. So let's go ahead and look at that. And yep, we triggered it. So we should see 3 jobs, 2 in parallel. So you can see that both of these images are deploying at or building at once. And then the EC2 deploy to EC2 for the API is going to wait until the API builds. So you might be wondering why I'm not using Docker Compose. I think you could use Docker Compose. There's a whole section in Docker Compose docs that talks about production and how to do it. But I kind of wanted my jobs to be separate, and we're moving on to Kubernetes next week, and I wanted it to mirror how we will deploy to Kubernetes, which is separate jobs for building and deploying. So that's just why I'm not using Docker Compose, because I'm going to otherwise, I feel like we'd have one deploy step where we do the Docker Compose up, but 2 different build steps. And I just didn't like the way that looked to me and felt. But I mean, you do you. If you like it, go ahead and give it a try. It's all a big learning experience. All right, so now we are deploying our API image to EC2, which is exciting. So let's go ahead and take a look at that. So first off, I'm going to go ahead and stop my container. All right. So we can close that. I'm going to close that. All right, so let's go ahead and connect to one of our instances. Oops, and it didn't work. Let's go ahead and take a look. Command failed. Time to get a new job. Well, that's sad for me. All right, let's try to figure out why that might not have worked. Oh, and duh. Okay. So let's open this a little bit. Okay, so here we are saying that we're stopping a container name, and then we are naming the container name. Oh, and we're using the secrets AWS underscore repo, which obviously is not a secret that we have. So we do need to change that. All right. So it's not secrets AWS repo, it's secrets.api image repo. And then is that here too? Yep, secrets.api image repo. So that should be good. And then I also don't like this vars container name, because that doesn't make sense for when we're going to have a front end and a back end. So let's go ahead, and is this just in the deploy step? Yeah. All right. So let's go ahead and go to our secrets and variables. And let's take a look at, do we even have a container? So where's vars container name coming from? Oh, is this only secrets? Okay, variables. That's where it's coming from. Okay, so then let's go ahead and trash this. And then we want a new repository variable, and we're going to call this API container name, and then we'll call it API, add variable, new repository variable, and then we're going to call this front end container name, and then we'll call it front end, add variable. All right, so then API container name is going to be the name of this. So let's go ahead and see how many we have of that. Just 2, so we're going to change that to vars.api container name. All right, so let's go ahead and do get status. Yep, that's all that changed. Get add, get commit -m, and then our message is going to be edited environment variables. And then you don't need work quit because I'm using -m. Okay, so funny story is at work, I do a lot of pair programming and everybody's been commenting, every new developer I work has been commenting that I use like the Vim screen to do all of my commit messages and that everyone else uses -m. So I've been trying, but honestly, I feel like I don't love it. I guess let me know in the Slack channel if you guys like using -m or not. All right, so we're building again. I'll go ahead and pause here because we don't need to watch these build. All right, so we built our API image and our front end image, and then now we're deploying to EC2. So hopefully that works. We're waiting for the commands to complete, and yay, we did it. That's exciting. All right. So let's go ahead and look here. We should be able to say curl local host at port 3000 and we get hello world. Perfect. So that's exactly what we wanted. All right. And so now our next step is let's just go verify that we have our image in ECR for the front end. And we do have 2 images there. All right. Now that we have our front end image built, we want to actually deploy it. Could we pull and run it from here? Yes, but I just don't really feel like doing that because I feel like we've done the manual route quite a bit. Let's just go ahead and jump right into the creating the job. All right. So I'm going to go ahead and copy my deploy API job because we should be pretty similar, I hope. And yeah, let's go ahead and then it's mad because we're naming it API. So let's name it front end. All right. And then let's go ahead and make our deploy. This one's going to be called deploy API to EC2. So this one is going to be deploy front end to EC2. It needs the build front end step. All right. These secrets should be fine. So configure AWS credentials, good. Log into ECR, good. And then we want to pull and run Docker image from ECR. All right. So we want to run this on our instance 1 and 2 still. Yep. We want to pull Docker image and run it. Perfect. All right, let's take a look at this. Our registry is the same. We just have 2 different repositories in our registry. So we're going to stop, but we're not going to stop the API container name. We are going to stop the front end and we're going to spell it correctly, container name. All right. And then we will go ahead and pull our front end image repo, our front end image from our front end repo. All right. Then we will go ahead and run our front end, which runs on port 80. And we'll map that to port 80. We don't have a database to host on our front end, so we don't need that. We don't have a database username, so we'll delete that. We don't have a database password, so we'll delete that. And we don't have an environment variable on the front end. All right, perfect. We will then name it vars dot front end container name. We'll pull that from our GitHub. And then we will go ahead and this is where we're going to run that image that we pulled already. So we'll have to change this to use the front end image. All right. So that to me from first check looks good. All right. Then we're going to wait for the commands to complete on instance 1 and instance 2. And then we'll have success. So I'm going to add your front end is up and running. That sounds good. And then I'm going to add the same message, but instead for API on the back end. So yay, we did it. And then we'll say your API is up and running. All right, so I'm going to go ahead and get status, git add, added, deploy, front end step. I guess it's technically a job, so we'll write job, and then we will push it up, which will trigger the workflows, and we will go ahead and get started. It's going to rebuild everything. So I'm going to go ahead and pause while it rebuilds. But let's go ahead and take a look at how these two jobs are running in parallel. Perfect. All right, pausing here, and I'll come back when the images are deployed. All right, sorry, I went and folded some laundry, but all of our jobs are now done. So let's go ahead and take a look. All right, so if we curl localhost at 3000, we get our hello world, which is lovely. Let's now curl localhost at port 80, and whoop, whoop, we get our React application HTML file back. All right, so that is awesome and exactly what we want. Let's go ahead and check our load balancer and see what's going on there. So click into our load balancer, look at our target group, too healthy. So that's looking good, or is it? And then let's go ahead and load this up. Well, this is nice in that we see hello world, but I was expecting to see my front end. I actually wasn't expecting to see my front end because we didn't make those changes to our Terraform. But in the next video, that is exactly what we'll do. So let's try to figure out what's going on here. All right, we'll debug a little bit. So we have our load balancer, which is accepting HTTP traffic. All right, and then it's forwarding all traffic. So any traffic that hits any HTTP request that comes into our load balancer is getting forwarded to our target group. But our target group is just going to be our instances at port 3000. All right, so we're just automatically forwarding traffic to our API, and that was fine when all we were deploying was an API. But what we want to do is we want to make sure that we can forward traffic to our front end when we come into that HTTP, when we hit it with HTTP traffic instead of our back end. All right, so let's take a look at what's happening with our load balancer, because that will tell us what we need to edit. So here we're listening for HTTP traffic, which just happens to come on port 80. All right, any traffic that comes in then gets forwarded to our target group. Let's take a look at our target group. Our target group has 2 registered targets, and it's both of which is going to be port 3000 on our private instances, which is going to go to our API. So I think what we need to do is do some editing, okay? Let's edit first in the console, and then once we get that working, we'll have a better idea of what we need to edit in our Terraform code. Also, excuse me because I have the hiccups. Okay, so we're going to back up a little bit to this place where we have one rule. This is just a default rule, and it just says immediately forward all traffic to the target group. All right, but that's not what we want. We want to add a rule. Let's call this API. All right, and then we need to add a condition. The condition is going to be based on the path. So we're going to say if we have the path API next, then we are going to forward to a target group. All right, so we'll go ahead and use the coding with Kali target group because that is our API. All right, then we will click next. So then otherwise, we're going to forward to this target group, which doesn't really make sense. Let's go ahead and put priority 1. All right, and then let's say next. So if we get anything with the prefix added onto it, the path of /API, it will forward to our coding with Kali target group. Let's go ahead and create that. All right, let's go back. Let's go to our target group then now that we have, and looks like we can delete it, but not edit it, which is not great because what I wanted to do is rename it, but it doesn't look like we can do that. So we'll just have to remember that the coding with Kali target group is our API. All right, let's create another target group instances is fine. Target group name, we'll say coding with Callie. Front end, target group. All right, choose a protocol for your target group that corresponds to the load balancer type. So we can either do HTTP, HTTPS. We'll just go ahead and leave it at HTTP. We'll do coding with Callie VPC. That's fine. And we will click next. All right. So now we need to register targets. We'll register our 2 private instances, ports for the selected target, ports for routing traffic to the selected instances while our Nginx is running on 80. So 80 is fine. So let's include as pending below, and let's create the target group. All right. So now we have a front end target group. All right. So let's go back to our load balancer. And you can see when we have HTTP traffic, let's go ahead and manage edit listener. Forward to front end target group. Go back to our load balancer. All right, so HTTP traffic comes in, it gets forwarded to our front end target group based on the 2 rules, okay? If it has an /API, it goes to the API. If it otherwise, it goes to default, which is the target group, which doesn't make sense. So let's go ahead and edit this rule. And yep, that's what we want. Save changes. Let's refresh. Okay, so it goes to the front end. All right, so now let's go ahead and hop back to our EC2 instance. No, let's hop back to our load balancer. Sorry, I'm a little all over the place now. All right, let's take the DNS name and let's plop it in there. The idea is we should see a React app if that worked. It's taking a little longer, and we got a gateway error. So let's go ahead and take a look. 0 healthy, 2 unhealthy. I'm curious if it's just a matter of time. So what I'm going to do is I'm going to go to my instances and I'm going to go ahead and just ping port 80 and make sure that we're getting a response, because if we are, then the health check, which is that just / should work soon. So curl local host at port 80. All right, and we get a React page back there. Let's go to the second instance and connect. I'm going to say curl local host at port 80 here, and we get that back. So hopefully it's just a matter of waiting for those to switch to healthy. Let's go to the health checks. So let's make sure this is in the right VPC while we're waiting to. Coding with Callie VPC. All right. Kind of looking around. So it's going to hit it on port 80 and port 80. Health status details, request timed out. All right. Well, I'm going to pause and I'm going to let it wait a few minutes and see what happens, do a little bit of debugging, and I will be back in a few. I think I might have found the culprit, and that is going to be the security group for private instances only allows traffic in on port 3000, and we need to add a rule saying that we can have incoming traffic on port 80, and that would be from the load balancer. So let's go ahead and save that rule. All right, and so now when we go back, we should hopefully be able to see these go to healthy. So I will pause and wait a few minutes and see if they go to healthy and if that was the issue. I didn't need to wait a few minutes because I actually went over to my load balancer and I went ahead and refreshed the page and I see my what needs to be done. And yeah, so that fixed it. It was a security group issue. These still say unhealthy, but we'll wait on it. All right, so let's go ahead, and it makes sense that I wouldn't see anything because there's nothing in the database, right? Let's go ahead and try to add a to-do and see what happens. And dang it, nothing happened. Let's go ahead and inspect and see what's going on. So we have failed to load resource, error connection, refused localhost 3000 / to-dos. All right. And so we have our first issue. Our first issue, right, is that we changed our listener and rules to say that if we hit /API, that goes to our API. But you can see our front end is not trying to hit /API. It's trying to hit localhost at 3000 / to-dos. All right. So that is what we need to do first is we need to, all right, let's look at this. Still unhealthy. You can do it. The first thing that we'll need to do is we need to edit our API and front end to use /API. You can also see with API, if we go and look at all of our routes, none of our routes have /API on them. So let's go ahead and start the server locally. And you can see that we have /to-dos and just /, but nothing with API. All right, so in the next video, that is what we are going to do is we're going to fix this API prefix issue. I really wish that this said healthy because then I would end the video and yay, it does, to healthy. So those were the things that we needed to fix with our load balancer. There's a few things that we need to do on our code now to get it up to speed. And then also we did that manually. So we're gonna have to remember what we did and translate that into Terraform code. All right. So now that we have our load balancer kind of working in terms of the load balancer is doing what it needs to do, we now need to make sure the application follows suit. I'm going to close out of all of my deployment files because I don't really need those. I'm actually going to work in the API. I'm going to go to source. I'm going to go to main. And you can see that this is where we're creating our app. So we can go ahead and use @ and of course I'm going to forget what it is. So let's go ahead and go to NestJS global prefix. As it says, this is going to set a prefix for every route in our application. All right. So like it says, I can just say set global prefix and yep, I want to set it to API. So now what you can see is everything in here just now mapped to /API /to-dos ID, right? Everything has /API now on it. Perfect. So that's the edit that we needed to do on the back end. Just one little line. Now let's go to our front end and we have a little bit more to do. So in our app.tsx, we have 2 calls, right? So here we have an Axios call. So instead of localhost 3000 /API /to-dos, all right? And then we'll add the /API, right? Because if we want to use localhost and then do we want to use localhost? But we'll deal with that later. We want to go ahead and use the prefix API to tell the load balancer, oh wait, we're not making a jump to where we're at. I guess I'm trying to figure out if I want to do a gotcha moment. And you know what? We don't need to do a gotcha moment. We're also going to change localhost. So let me walk through what would have happened. So what would have happened, and feel free to go through this too, is Chrome has some security measures basically, and this has to do with CORS. So if you would leave it as localhost, you would get a CORS issue, okay? Because the load balancer I'm going to the load balancer, and then the load balancer is forwarding to my target group, right? So I am at this URL here. Then when I'm making a request to the back end is like, this is weird. This website is making a request to localhost. I'm going to flag this, and it's a CORS issue. We're not going to let it happen. Okay. I looked into it because I was kind of like, localhost should work in a sense because you are on the same host, right? You're just in different containers. So I try to go the route with like, oh, well, let's make sure the Docker containers are in the same network and then they communicate. And it seems to be a CORS plus Chrome issue. So in order to avoid that, instead, I'm going to use a variable for host instead. So I'm just going to add it right here to be easy, but I'm going to say constant host is equal to window.location dot, is it dot host or dot host name? Looks like there's both. All right, host returns the location object's URL host and port if different from the default port. All right, what does host name do? Can be set to navigate. I think it's going to be host name. Let me go ahead and check real quick in my notes just so I don't mess this up terribly. And we're gonna see. I could also be like looking this up on Google instead, but yeah, host name is where it's gonna be at. All right, so instead of saying that we want to get http/localhost at port 3000, we are going to instead completely erase that and we're going to put in host instead. So the way we use a variable is then we have to use our backticks. And so now this is going to be at http/host/API/todos. And then our host when we're locally working is going to be localhost. And when we are working here on our deployed application will be this. But now I'm feeling like a little bit conflicted if this is going to work locally in addition to, so I'm going to go ahead and it's trying to run start dev. I'm going to instead just do run dev. Let's try to get it working locally and see if this is going to mess up my thing. And I think it is because of the lack of port. Connection refused. Axios error. I'm trying to look at what the message is, but my dog is barking. I'm going to pause and let my dog in and be right back. All right, I am back. We're having an Axios error, and that's not working. I am going to try to console log what my host is, because essentially what I'm trying to do is I'm trying to come up with a solution that works both when we're deployed and when we're not. So host is localhost. Now I'm going to try this. If we just leave host, and host is localhost at 5173, which does not help us for making a request to the back end because that doesn't work. So we do want host name. All right, but when host name is just host, we don't have a port. So if I add the port here, what I'm wondering is if this will work then on the deployed version still. But you know what? We could try and see how things work. I'm going to go ahead and console log host in my deployed version so that way we can see what it comes out to. I'm going to leave the 3000 in to see if that even matters. If it does end up mattering, we can use an environment variable and do like a conditional URL. But anywho, we essentially want to change this. All right, the next thing I'm going to do is we don't need to have the host declaration there, because if we have it there, then it's just always I'm going to have it anytime I want to use it. So I'm going to actually export it here, and I'm going to say export. All right, wait, the Copilot was about to give me. Oh, nice. Okay. So we're going to export host, and then we will in here console log host, and then we can use it. All right. We could also add some logic, and we could say something like if host is equal to local host, then we'll like make host equal to like at port 3000 or whatever. All right. But I'm curious if it will just work adding the port in there anyway. Fast refresh only works when a file only exports components. Use a new file to share constants. All right, so it doesn't like me sharing host there, which is fine. Let's go ahead and we can say like constants.ts, and then let's add that. And we're gonna go ahead and import from constants. Now everyone should be happy. All right. So then I'm gonna copy this URL. And I'm going to paste it in here. All right, and then there's one more in to do. Get rid of that. And then we will have to import host from const. All right, so now I should be able to get status, add, added API prefix, and fixed Axios calls on front end. Git push. All right, so now that should be building. Let's go ahead and do DIP and go to actions. And yep, it's building. I'll go ahead and pause until it's done. All right, looks like the front end is done and the back end is still deploying to EC2. All right, so I'm gonna go ahead and get out of some of these. I'm gonna get out of my local host here. I don't need NestJS anymore. All right, so that still comes up because the front end is deployed. Let's go ahead and take a look, and it doesn't look like we have any issues in terms of it saying it couldn't go get something, and it is logging the host, which makes sense. So I'm feeling good about it so far. Looks like we went ahead and finished, so I'll close out of that, which wasn't really necessary. Targets look healthy. All right, so let's go ahead then, and if we change this to /API, we should hopefully get an empty or a hello. Interesting. And we do not. Do I need to add the port? Which we shouldn't need to add the port. Something's going on. But I should enter API, and it should be like, look at you. I'm wondering if my priority of my rules is wrong. No, because it's saying the API is the first priority. Well, anyways, this feels like it doesn't like this. Okay. Let's take a look. If the pattern is /API, it should be forwarded to the Coding with Callie target group, which is port 3000 on the local host. But it looks like those are unhealthy. So I think because those are unhealthy, it's backing up to the other rule, which is just send it to this. Okay. I'm curious if those are unhealthy because our health check is /. So let's first check here. Let's first check our instance. And let's do curl localhost at port 3000 / API. All right, so if I curl it at localhost, it does that. So I'm curious if I need in my health check to have these / API. It doesn't fully make sense to me though, because like of the target group, but because like the prefix then forwards it to the target group. I think I've confused myself a little bit, but I think that this will sort it out. So 404, let's look up. I think that's not found. Yeah, 404 is not found. Okay. So I'm going to wait a second and see if these turn to healthy, and then we'll go from there. I think I'm going to, I'll just pause, but this video is getting kind of long. All right, so I refreshed the page and it says to healthy now. So I'm curious if I do / API. See, feel like we should be getting forwarded. I'm going to go ahead and try to add a to-do and see what happens. And unfortunately, adding a to-do does not work either. So I think I just needed to kind of hard refresh and / add the / after. Because if I hit / then I see hello world. And if I do / to-dos, then I go ahead and see an empty array. So here's what I'm going to do. I am going to use Postman now to add a to-do to my database, because now I have the endpoint working so I can hit my database. And the reason why I'm going to do this, is because I want to have a better way to check. All right, so this is the description of the first to-do. Sure. I want to have a better way to check if the front end is working. So now if you look, you can see there's no to-do loaded. So even though there's no errors that come back, it is not working. You can also go to the network tab and then refresh the page, and you can see that it has a pending. So it's like trying to make a request to wherever we're making a request, but I think it's going to time out because this request is not finished yet and it's stalled. All right. So what I'm going to do then is I am going to look up host first. We apparently didn't save that file. All right, so that we just made host. Let's go look at where we added it in the port and let's get rid of it. This will break it locally, but we can fix that with some changes. All right, and I'm going to go ahead and give that a try. Get status spelled correctly. Remove port from Axios request. We didn't think that that was going to work, but you know, you live and you learn. Always good to experiment and try to see what's going on. All right, so now that is going to be doing the GitHub Actions workflow while that's building. Let's go ahead and kind of play around and see if we can figure out how to make things work with locally. Okay, so this is our load balancer version. Let's go ahead and open the local one. All right, so now we have our local version and you can see nothing's coming back. All right, so let's go to our constants and then let's do let host, nope, let host equal that, okay? And then we'll say if host is equal to local host, then we're going to reassign host and we're going to say host is equal to localhost at 3000. Okay. Or we could do like host plus 3000, but we're just going to do that. Okay. And then can we export? How does this work? Export host. All right, so now it's working locally, so that's good. And hopefully this works in a deployed fashion. Then we can deploy this and see if that works deployed too. So it looks like our front end is fixed now. And if you look, our front end is successfully communicating with the back end, which is now fully deployed. Let's go and take a look if we see any issues in the console. We still see our host, so we'll have to do that. Let's mark as complete. And you can see that that marked as complete. If we edit this, you can see that that edited it. Edit that. You can see that edited it too. And the changes persist. All right, so yay, we successfully deployed our front end. Let's delete that console log and try to update with these changes and make sure that nothing breaks. Trying to deploy a fix that will work locally too. All right, so we'll push that and let that load. And then the next thing that we'll need to work on, if that works, which fingers crossed, the next thing that we will need to work on is making sure that our Terraform is all up to date and doing a quick run through of this. Yep, we'll go ahead and work on that after this loads. I'm going to go ahead and pause my recording, wait for this to load, just verify everything's running both locally and deployed, and then we'll wrap this challenge up. All right, that wrapped up and worked. So let's just refresh locally. It works. Check. Deployed. It works. Make sure we can make more API calls. Check. All right, let's make sure we can add. Whoop. All right, very cool. So we officially have our front end deployed, but we skipped a few steps by doing something manually. So let's make sure that our Terraform's all up to date in the next video. See you in a minute. All right. So what we're going to do is we're just going to compare our manual settings that we changed, try to figure out what we changed, and take some notes in our Terraform doc. So that way we can try to make sure that when we destroy our Terraform, everything destroys fine. And then when we apply it, everything works. Okay. So let's go to our load balancer first. All right, our load balancer right now forwards to our front end target group. So let's go ahead and take a look at where that is in our code. So this is database. All right, so let's add a note. So right now this target group is pretty just general. So we want to rename. So this is the API target group. All right. Then we need to go ahead, and so that would be the target group and the target group attachment. So let's go down here and we want to say add a target group for the front end and attach. Add a target group and target group attachment for the front end. All right, cool. So that should be good. So then we have a listener, and the default action is to forward, and that's just forwarding it to our target group that we have right now. So we want this to be changed, and we want to say make default action forward to front end target group. All right. We also, you can see that we have two rules, the default rule, which is here, but then we want to sit here, add another resource where we're to say create a listener rule for the API. All right, yeah, we can say for the API target group. All right, and that should, I think, handle that with a health check 2/API. All right, so that should be good. All right, we also edited a security group. So let's go and look at that. We added an inbound rule for port 80. So let's go up to our private. So private ingress rule, database. Let's go up. I think this, okay, yeah. So then we want to also, I'll make the note here. We want to add an ingress rule to allow traffic on port 80 from the load balancer. All right, I think that should be everything. I'm going to go now and try to manually delete some of these things that we added. So port 80. Let's see. Okay. So that is fixed. Let's go to our load balancer and see if we can fix this. Let's delete this rule. Let's confirm. Nice. All right, so then let's go ahead and edit this rule. We're going to send it to just the normal target group. Refresh. Okay, cool. So then let's go to the Coding with Callie target group. That's good. I'm trying to just look, oh, and then here's target groups. Let's go ahead and delete. Yes. All right. So now I think we should be good to Terraform destroy. So Terraform destroy dash var dash file equals secret.tf vars. Is that the right name? Yes. So let's see if that's going to work. And then we'll go ahead and click yes. I kind of want to stay on the video though, because if I run into any delete issues, I want to make sure I can kind of pop back in and debug. So I'm going to wait for it to give me a yes or no or an error. And then once I click yes, then I'll pause the video here. All right. See if it'll get going. Perfect. I will pause and we'll see if everything deletes. All right, we successfully destroyed all of our resources and now we can make our edits. All right, so we have our notes in our Terraform code. So all we have to do now is go through where the comments are and add those changes. Then once we get everything changed and we think we're good, we'll go ahead and apply and redeploy. and see how we're doing. Okay. Yeah. So let's go ahead and add the ingress rule to allow traffic on port 80 from the load balancer. Okay. So we already have this resource, which is an ingress rule allowing traffic from the load balancer on port 3000. So we should be able to just copy it down here and change this to 80. And then we need to change the name because you can't have two resources with the same name. So we can say allow TCP traffic. I think we'll probably just change it to allow traffic from load balancer to API. And then we can change this to allow traffic from load balancer to front end. All right. So that is going to be our first change that we need to make. All right, let's keep scrolling and see what else we need to do. All right, so we need to rename this target group. Rename, so this is the API target group. Yep, so our API is going to be running on port 3000. So instead of naming this just like coding with Kali target group, we can do coding with Kali API target group. All right, which then when we attach, we will have to make sure that we, we also want to do API target group here. I don't know if we necessarily need target group because we're saying that we're having the resource is an AWS load balancer target group, and then this is for the API. So I like that naming better. So then I'll go ahead and change this, right, to AWS load balancer target group. That's the resource. The name is .api.arn. All right. So we have the target group for our API. Now we need to add a target group for our front end. So I'm going to just copy that target group and paste it down here. All right, so instead of API, I can do Command D to highlight both of those. I guess all three of those and change this to front end. All right, our front end is running on port 80. So we'll change that there and we'll change that here. All right, so we have a target group for the front end and it's attached to each of our private instances. Perfect. All right. So here we are saying that we have a listener and it is listening for HTTP traffic. And then when we get HTTP traffic, we are forwarding that traffic. All right. But we need to forward that traffic to the right thing. And our note is saying that we want to forward that traffic to the front end. And so that is going to be the front end ARN. All right, so we only have one comment left, so we're doing pretty good. So we want to create an AWS listener rule, which, thank you, Copilot. I'm not going to call it listener rule. What am I going to call it? API, maybe? And then let's go ahead and add the listener rule. So I am going to pull down a Chrome browser to use. Because I don't want to just go with whatever Copilot tells me. So I'm going to say Terraform, ALB, listener rule. All right, and we can go to the Terraform registry and look that up. All right, so we have our listener ARN and a priority. So let's do listener ARN is going to be, let's take a look, listener.arn. And then we are going to have action is going to be type forward. And then we're going to have, yep, target group API. That's good. And then we need condition. And yep, we're going to use path pattern. Can we just do path? Is path not a thing? Okay, so I guess path pattern. And then we will do API slash and then anything because we have things after. So it'll be like API slash to-dos slash whatever, right? All right, so that looks good. The priority, I think the default priority is between 1 and 1000. Leaving it unset will automatically set the rule with the next available priority after the current existing highest rule. Okay, so then I think that would make this, well, this would be the, I guess we'll just see when it Terraform applies and make sure it's acting right. Okay, so we have created everything that we need. So the default action is just to forward traffic to the front end, but if it has this prefix or this path, then it's going to forward it to our API instead. All right, so I'm going to go ahead and Terraform apply and then see if any errors pop up so we can fix it. And we do. All right, 180. Yeah. Oh, I think it's because we already have target group attachment. So we'll say maybe instead of target group attachment, we'll say API attachment. And then maybe instead of target group attachment here, we'll say front end attachment. All right, let's try again. Oh, I always do this. Okay, so then we need to do, why? What is going on? I don't know why all right, so Terraform apply dash var dash file is equal to secret dash tf vars. All right, and then we'll say yes. I'm gonna go ahead and pause and then I'll resume when it finishes. All right, it's still creating, but while it's creating, I should be able to at least get my instance IDs because I think those are ready to go. Let's go ahead and take a look. I'm gonna go to EC2, check out my instances. All right, and I'm gonna copy my instance ID for my one, paste in there. And then my instance ID for two, let's do the same thing. Oops. There we go. All right. We also need the database URL for the host, but I don't think that's ready until. Oh, but we have the endpoint, so that's good. So we can go ahead and update this. All right. So that should be pretty good. And then as soon as our database instance is ready, then we should be able to just rerun our latest action, which will rerun all of these things. We'll have to rebuild because we wiped out Terraform before, and then we should be able to test it. I'll go ahead and pause again until it's finished loading. All right, so all of our resources have been deployed. So let's go ahead and rerun all of our jobs. I didn't change any of my code, but I shouldn't need to because the last time we ran this, when we manually had added all of the load balancer and security group rules and stuff like that, it worked. So I'm not going to change anything on my code because I'd like to see if it can work by just doing the Terraform. If I change too many things at once, then and if it doesn't work, we won't know what broke it. So those will go ahead and be built here. Hopefully it doesn't take too long and then we should be able to see what's going on. So let's go to our EC2. We'll head over to our load balancer. So that way we're ready All right, and let's take a look. So we're listening for HTTP traffic, and then we're forwarding that traffic to our front end target group. There is an additional rule there. So if we have the path pattern of API with anything after it, we'll forward it to our API target group. Otherwise, if no other rules apply, we'll forward it to the front end. All right, that looks pretty good to me. Let's take a look at our target groups. They should all be unhealthy because we have no applications. And why are they unhealthy? Because we're running a health check and we're pinging our target group right at this path for the front end, which would make sense on port 80. We would hit that path and it doesn't return anything, then it fails, right? After 5 or after 2 failures. Now there's no application in there because we're still building it and deploying it, which now there will start to be some, right? But that's why it's saying that it's unhealthy. You can also go to your monitoring page, and here you can look at the unhealthy hosts, how many we have. So here you can see that we have 2 unhealthy hosts. And those are pretty, let's zoom, maybe do like 15 minutes, even 5 minutes. All right, so if you do 5 minutes, you can see a lot better. You can see that we have 2 unhealthy hosts up till 4:30 or up till 14:39. So that's just the latest. It's a little bit delayed in terms of data. All right. So let's refresh it and see if we get anything different. So it looks like it's still saying it's unhealthy. And the reason why it's still saying unhealthy is because it needs 5 consecutive checks in order to of success before the host will turn to healthy. So if we look at the health check, it's pinging every 30 seconds. All right. And then waiting 5 seconds to time out and say, like, it didn't work. So, in order to get to healthy, it needs 5 consecutive checks. So, if you do 30 times 5, we're going to get 2.5 minutes. So, minimally, it's going to take 2.5 minutes to switch over and say that it's healthy. All right, so now it's switched over and we said that it's healthy. You can check that with the monitoring tool too to like see what's happening. So it was unhealthy until here, and then it looks like at 14:36, it became healthy. So yeah, that's how you can use the monitoring tools. So now let's go ahead and look at our API target group and see how that's doing. And it looks like we have 2 unhealthy. So let's go take a look at our Terraform. So we need to find our target group API. All right, it looks like for our target group, we don't actually have a health check coded in there. So let's go ahead and add it. All right, but it's not going to be /API/help. We can just say it's just /API. So it's going to ping the API prefix, which should give us that hello world message. All right, let's go ahead and, I mean, technically we don't need to add it for the front end because the health check is just the like default route, but we might as well add it. All right, so that way we can be clear. So let's go ahead and say Terraform apply every single time. I always forget that file. So this will go ahead and change the health check, which we could do manually, but we're trying to make sure everything is set up with Terraform. So if I refresh my page here, and then I go over to the health checks, you can see now that the path is API. I'm gonna go ahead and pause this video here because again, it's gonna take about 2.5 minutes to update and go to healthy. So I will return when it's healthy. Or if in 2.5 minutes it's still not healthy, I will return and we'll debug. All right, we are at 2 healthy. So we should now be able to go and take a look at the actual application and see how we're doing. So we have no /API here, so we should see the front end, and we do. Let's go ahead and open up the inspector here and look at the networking. All right, and I'm going to refresh the page, but you can see that we have a, well, where do we have we have a response of an empty array. So that's good because that means that we had a successful response. So yep, 200, okay. And we just got an empty array. That's because there's nothing in our database yet. So if I add something to my database and add it, you can see that then we had another request and it responded with our to-do that we just added and a 201 created response. All right, if I edit, it's going to edit, so that's looking great. All right, if I edit here, it also edits, so that's looking great. If you're noticing the lag in editing, it's just I just was lazy with React. I should be adding some like automatic state updating. I should also add like a loading spinner and stuff like that, but that's not really the purpose of this tutorial here. All right, so it looks like we are successfully doing what we got to do. All right, so I'm going to end this video here. And then in the next video, we're going to go ahead and make some updates to make sure our GitHub Actions workflow is going to properly update things. And we're going to see how you would kind of add a route or something like that, or add a feature on your front end and then make sure it still works when you deploy. All right, so now that we have our deployment, Terraform, and workflows we think ready, I want to show you kind of how you would deploy your application kind of in the beginning of working on a project, and then you can add features and go ahead and keep working on it. And then just every time you push to main and you decide like, oh, this feature is done, I'm ready to go, it gets deployed. Okay, so this is what I would do. First, I would get so this is like our deployed version, right? So I'll just pull that over here. Let's go ahead and get our local environment up and running. All right, so our API is started. It looks like our front end is already running, but just to be safe. All right, so yep, and then here are the to-dos from my local database. That makes sense. Perfect. All right, so now now I'm just editing locally. So what I would do is I would first of all, let's check everything's up to date. So I would do git checkout -b, and then I would say something like delete feature. Okay, this is going to create a new branch on my GitHub. So that way, when I'm pushing to my branch, it doesn't trigger the workflow. How do I know that? Because on push to main is when this is triggered. So let's go ahead and take a look and make sure that that checks out. All right, so I'm going to go ahead and say git, oops, I just started a server. All right, so I'm going to say git status, nothing. Let's just do git push. So it's going to give you this command because this is our first time that we're pushing to this branch. So you're just going to make sure that the GitHub has the branch too. So if I look at my GitHub actions, you can see, let me refresh just to be sure, there are no new actions running. But if I go into my GitHub, you can see that there is now another branch, and that's the delete feature. Okay. So what is the point of this? This allows me to locally work on my branch and do whatever changes I want to do, make sure that those changes work, add some testing, get some feedback. And then when everyone signs off on the team that like, yes, this is good, then we can create a pull request and merge, and then this will automatically deploy. So what do I want to do? All right. The only thing that I left out that our API can do that our front end doesn't do, if you look in the to-dos controller, is that our app can delete a to-do. All right. And I want to make sure that our front end can do it too. Okay, because our API is able to handle it. Let's go ahead and make sure our front end too. So I want to make a delete button on the to-do, right? And I'm not going to worry about making this like super legit because at the end of the day, this is just to show you like the workflow for deployment. So I'll just add a second button. You can see it goes down there. I'm not going to worry about conditionally rendering incomplete or complete. I'm just going to write hard code delete. All right. Then we have our on click action. All right. We are not setting complete or calling the edit to do function. Instead, we are going to call a function called delete to do. React's going to be mad because there is no delete to do function. So let's go ahead and edit. So we can say const delete to do. All right. And then, yeah, we will go ahead and make an Axios request. And this looks mostly good, to be honest. So let's keep it. So we're going to send a request to our host /API/to-dos. And then you can see that the way they're doing it is by adding it to the URL. Which, you know what? This is a good exercise because this means that we'll change something on the front end and the back end. All right, so we're going to say that we want to delete the to-do with the to-do ID, right? So each one of these is a component. So because we are on a specific to-do component, we already have that ID and it's in the URL. However, if you look at our controller, you can see that we are passing this in as the body and as the body here with an ID number. And that doesn't make quite as much sense. So instead, I'm going to change this to a param and we're going to call the param ID. And then we'll add the param here ID. Also, if you don't get all of this, that's fine. Consider taking the build in public challenge. You'll learn all of this in a lot more detail. The point of this video is mostly to make some edits to the front end and the back end on a branch and kind of understand what like a deployment and development workflow would look like. Okay. So now if you see, this has edited our route to adding a parameter to the route. All right, so now this should be good where we click on it, we make a request to that endpoint, and then we update the to-dos with the response. Okay, so I feel pretty good about this. Let's go ahead and give it a try. So I click delete, and you can see that that deleted, and you can see in the logs that it deleted where ID is equal to 1. All right. If I refresh my page, it's gone. If I go to right here, it was in my database, but if I refresh my database, it's now gone. All right. So now we have that working locally. Yay, us. So now we can go ahead and say git status, git add, git commit, and then we'll say added delete functionality. And let's say git push. All right. So how does this work now? Right? We pushed our delete feature. Let's say product's taken a look at it. They approve, all of our development teams approve or whatever. The way that we get these approvals is by creating a pull request. So you would add your reviewers, right? And then you would say why you did this, request from product to have delete feature on UI, and then you'd create your pull request. All right. Now my reviewers would review, blah, blah, blah. They would approve it, hopefully, right? Which you should have in your GitHub. But anyway, not super important for this thing. And then you would say merge your pull request. What this does is this takes what was in your branch and it merges it into main. Okay. So now you can see that if I go back here, I look into main and you can see that we added the delete functionality to the API and to the front end. And you can see that a workflow has started because we essentially, when we merged into main, we pushed to main. All right. So that it would be the workflow for how you would continue adding features and doing work on your application in your local environment, and then you would, when you merge your pull request, it would update the deployed version. All right, so we'll go ahead and wait for this to finish, and then we'll take a look and see how it all worked if our application has been updated. If you are feeling a little bit foggy on this, go ahead and create a branch on your own. Try to work through it with a different example. I mean, you don't have to change anything crazy. You could literally just change like one of the words in the content, right? Just to see if you can do this. If you're feeling like, wow, this is so easy, I got this, try to do another database migration, change something in your database, right? Really play around with it because this is the time to like use a simple project and kind of iterate on it with more complicated things and see how it goes. All right. So it looks like we're finished deploying. So I should be able to hard refresh by Control and Shift. All right, and now we see we have a delete button. So let me add another to-do just so we have some to-dos to work with. All right, and if I delete this one, it is gone, and I refresh it, and woohoo, it is gone. All right, so this sums up the challenge for the week. Things that you could do if you want to kind of keep on keeping on. I would say we still haven't really gotten to modularizing our Terraform because we just haven't seemed to have a solid amount of extra time at the end of each challenge. So, but you could give that a try. I'm going to go ahead and delete these comments because we did these to-do items. You could play around with adding new features to your application, and you could look at alternate ways of doing this. Do you want to try using Docker Compose? We didn't try to use Docker Compose. Ultimately, because the React application, while the files are in your container, the browser, right, Chrome is what is running our React application. So that's why that's why I ended up using the load balancer and the path to the API to communicate between it because we're not really having two containers talk with each other, which is the idea of Docker Compose is it automatically does the networking for you so your containers can communicate, but React is run in the browser, so you're not really, it's like the browser communicating with a container, right? But that would be something to see if you can do this with Docker Compose, if you like it, if anything changes with your Terraform, play around with it, see what you can learn, post in our Slack channel because I would love to learn more about this too. All right, see you next week.